Alright, I'm doing a reassessment on chapter 14, and I'm proving the dipole formulas for the axis, on axis, and perpendicular to the dipole. I started out with the formula E1 over 4 pi epsilon naught Q over R, and then R hat, and then I drew this picture right here. Maybe it's not so good. I could have taken a better picture, but I pulled it down right here. And what you're going to need to understand is that in most formulas they just use S for the whole thing, and I used S for each side. So that's going to be a bit confusing, but hopefully that'll be okay. And I started it from the area, so this would be S from here, and this would be negative S starting from this point. And so I knew that E perpendicular would be E plus E minus, and then 1 over 4 pi epsilon naught times Q over R squared, R plus 1 over 4 pi epsilon naught minus Q squared, R hat, magnitude. I don't know, I took a pretty bad picture, so it's kind of hard to read, but I pretty much took out the magnitude of negative R and positive R, and because I used the net formula to make these equal each other, is what it came out. So I figured out the net, which the x is the s, the y axis is y squared, and after all that I got s squared plus y squared, and that's your negative R. So that's on this side, and then your positive R ended up getting s squared plus y squared. I'm sorry, that's yeah, that's a positive. And so, and then with R hat, I just put everything on bottom, replace it on bottom, and on top should be your R vector, and and for negative should be S, Y, and 0, and for your positive should be negative S, Y, and 0. It's a little clearer picture, so this may help a lot more. And then E perpendicular, I added them all up together, and then I took out the common factors and came out with this. And then I replace a negative with a positive, and so that's why you see this right here. And then you end up getting a vector. Oh, I'm sorry, I actually took out the bottom also because it's all the same. I brought it over here, so that's why you see that. And so the vector is actually negative 2s, 0, 0. In the formula on the book it's s, but I used 2s. Then you'll see that I just rewrote everything from there up here. Brought out the negative and the s. The reason why this became a 0 is because positive y, negative y. So it's negative 2s, 0, 0. And then I said I brought out the negative. I'm trying to see where I did that at. This was some of my side work. I'll move on. And this is what I ended up with. I brought out the s and kept the negative in there. It's newtons over coulomb, and for the note I just putting that basically s in the book, and s for me is they're the difference but the same. That's why there's a 2s. And that's just, I guess it's going to be stated with the s's right here as well. So this was my formula, and then I did it on the axis, and same thing, I used the s and the negative s for that. And this is where I started out with the formula, as well as I did the R hat, the R magnitude of the vector, as well as the negative, positive, and negative. And then this is the R hats I ended up with was 1, 0, 0, as well as 1, 0, 0. Sorry, it's actually a little hard to read my work, so I can imagine what you're going to go through. But a lot of this was side work. You can look over that, but it's nothing really important. I just brought that work over here on this side. This was kind of just a side work page. And then the e-axis, I got q 4 pi e to epsilon naught 1, 0, 0, and I brought it out right here and I cross multiplied. And so this is what I ended up with, and I implemented that into the equation right here because that's what it's times with. So it should be 4as, a minus s squared, a plus s squared. And if a is much greater than s, then you replace that, and that's your answer. And like I said, this is the note with the s. Thank you.